Hello everyone and welcome back to how to make a Metroidvania Part 8, where we'll be teaching you how you can create a Metroidvania like Hollow Knight in Unity. In this episode, we'll be creating the Mantis Claw, allowing even more options to the player's mobility, pickups for all the abilities and spells, pickups for increasing the max health, and the Soul Vessel Fragments mechanic. Finally, we'll also be covering the inventory to show what the player has collected. These mechanics will definitely allow the player to fight and move in new and interesting ways as they progress through the game, just as Hollow Knight intended. Okay, before we begin, let's make the bench a prefab as we forgot to do that in the last episode. Alright, without further ado, let's get this show on the road. The first thing we'll do is the Mantis Claw. This is an ability in Hollow Knight that allows the player to cling to walls and jump from them. In the player controller, we'll create a section for wall jumping. Then we'll create a float, wall sliding speed. I'll default this to 2. A transform, wall check, which will, like the ground check, tell us if the player is hugging a wall. A layer mask, wall layer. Another float, wall jumping duration, which is how long the wall jump will be for. And a vector 2, wall jumping power. Now we'll add a float, wall jumping direction, and bools is wall sliding and is wall jumping. Great, now we can create a bool walled. Like the grounded bool, we'll check if the player is at a wall. Then we'll create a function, wall slide. In here, we'll check if the player is walled and not on the ground. And we'll also make it such that the player needs to be actively going into the wall to make it work. So if that's the case, we'll make is wall sliding true, and set the player's fall speed to the wall sliding speed. Else, set is wall sliding to false. Next, we'll create another 2 functions, wall jump and stop wall jumping. In stop wall jumping, we'll simply set is wall jumping to false. Now in wall jump, we'll check if is wall sliding is true, and set is wall jumping to false. Then, we'll set the direction to wall jump in. Basically, if the player is facing left, we want the wall jump to be to the right, and vice versa. And finally, make sure the stop wall jumping doesn't run. Now if the player jumps and is sliding down the wall, we'll set is wall jumping to true and make the player wall jump at the wall jumping power. We'll also reset the dashing and air jumps so they can do mid-air acrobatics if they so desire. Then, we'll ensure that the player is facing the correct direction when they wall jump. And finally, we'll call the stop wall jumping after the wall jumping duration. In update, we'll call the wall slide and wall jump functions, and set move, flip, and jump to only run if the player is not wall jumping. Now in the editor, we'll create a transform, wall check, right in front of the player. Assign the values to the inspector and save the prefab. I'll set the wall layer to be the ground layer as well. Now let's test it out. Splendid! Okay, now with the wall slide done, we'll make sure the player can't use it when they start. In the player controller, we'll create a bool, unlocked wall jump. Next up, let's create a 2D sprite circle and name it unlock wall jump. We'll add a trigger collider and a rigid body to it. Make sure to set the body type to kinematic and detection to continuous. Next, give it a light so we can see it in the game clearly. Now we'll create a script, unlock wall jump. In the script, we'll create a bool, used, and an on trigger enter. We'll set used and unlocked wall jump to true if the player enters the trigger and then destroy it. Now in void start, we'll destroy it if the player already has unlocked the wall jump as a precaution. Back in the player controller, we'll make sure they can only wall jump if unlocked wall jump is true. We'll make the unlock wall jump a prefab and test it out. So before touching the unlock wall jump, I can't cling to walls, but after touching it, I can. Awesome. Next up, we'll create some particle effects to make it look better. So I'll be making it look similar to the player's blood spurt, but slightly different. But feel free to experiment with it until you find one that looks good. Make this particle effect a prefab. Back in the unlock wall jump script, I'll add a reference for the effect and instantiate it when the player interacts with it. Now if we try it out, great! Next up, let's make a UI for it when it's unlocked. In Hollow Knight, after unlocking an ability, a screen shows up with a description of the ability. So let's do that. Let's create a canvas and set it to scale with screen size. Then under the canvas, we'll make a translucent backing. We'll show the name and a description of the item. My description will be similar to Hollow Knight's, but I'll change a few things. Next, let's create an illustration for the ability the player just unlocked. No wizardry here, just UI images. Set the canvas to false by default. Now in the unlock wall jump script, we'll make a reference to the canvas and create a coroutine show UI. Here, we'll instantiate the particles immediately and set the canvas to true after a moment. Then after a while, set unlocked wall jump to true and set the canvas to false. Then destroy the game object. In the onTriggerEnter function, we'll call the show UI coroutine. Now assign the canvas, and if we test it out, it will look much nicer with a description of the ability just unlocked. Now we'll have to save this data so it won't reset. In the save data script, we'll create a bool, player unlocked wall jump, and we'll write it in the save player data and read and set it in load player data. If the load file doesn't exist, we'll default it to false. Now in the unlocked wall jump script, we'll save the data after we've unlocked the wall jump. Now we'll test it out. So we have an error here, as the player unlocked wall jump is new and hasn't actually been saved yet. And when we spawn in the player, we're loading it, hence causing the error. To fix it, we'll just save the game and restart. As you can see, now we don't have an error. So now we'll test out the wall jumping after we collect it and leave the game. Perfect! So now we'll have to create a version for each of the abilities. Simply just copy paste, rename, and make it an original prefab. So next, I'll make the dash. We'll create another script, unlock dash. Here, we'll copy paste the unlock wall jump script. We'll make it unlock the dash instead of the wall jump. In the player controller, make a bool, unlocked dash, and make sure they can only dash if it's unlocked. Create another bool, player unlocked dash in save data, and save right and set it. In the Unlock Dash prefab, we'll change the canvas UI to make it display the dash's details instead. Now we make sure everything is assigned properly and test it out. Great! Now we'll do the same for the variable jump. In Hollow Knight, spells also need to be unlocked, so let's do that. I'll do the side spellcast first as an example. Again, copy-paste one of the unlock abilities prefabs and rename it. In the player controller, we'll create a bool, unlocked sidecast. Just like the other unlocking prefabs, we'll create a script for this, unlock sidecast. Update the UI canvas to display the intended unlock. And then we'll do the same for the upcast and downcast as well. Now in the player controller, we'll make sure they can only cast in the intended direction if their respective unlocks are true. In save data, we'll create 3 bools for the spells: player unlocked sidecast, player unlocked upcast, and player unlocked downcast. And then we'll write, load, and set them accordingly. Do note that the order that it's loaded must be the same as the order in which it's saved, otherwise it can cause bugs. Finally, let's set everything to false and try to collect all of them again. Without anything unlocked, I can't use any ability or spell. But once I've collected them, I can. Perfect. Alright, with the unlocking done, we'll move on to the mask shards mechanic of Hollow Knight. In the player controller, we'll add 2 ints, max total health and heart shards, as they'll need to collect 4 shards to form 1 health point. We'll set the max total health to 10. Now copy paste the unlock ability prefab and name it increase max health. We'll also add a script of the same name. Make it into a new prefab. we'll change the sprite to the heart container and add another sprite as the fill. In the UI canvas, we'll do the same, but make the fill a radial fill image. Now, create a script, heart shards, on the canvas. We'll be using UI elements here, so add it to the namespace. Next, we'll create an image fill, floats, target fill amount, lerp duration, defaulted to 1.5, and initial fill amount. We'll then create a coroutine lerp fill. Here, we'll lerp the fill image from the initial fill amount to the target fill amount in the lerp duration. Then, we'll check the fill amount. If it's 1, meaning it's completely filled, we'll add to the player's max health and update the heart's UI. Then, we'll reset the heart shards to 0. Now in the increase max health script, we'll create a reference to the heart shard script. Destroy it if the player has already reached their max total health. Then in the show UI function, we'll set the heart shard's initial amount to the player's current heart shards count. Then, we'll add to the heart shards count and set the heart shards target amount as the player's new heart shards count. I'm multiplying them by 0.25 as they need to collect 4 for 1 full heart. And fills have a maximum value of 1, so 0.25 is a quarter. Finally, we'll call the lerp fill coroutine. We'll also decrease the wait for seconds here to 2.5 since the lerp duration is 1.5, so the UI won't linger for too long. Now in the save data script, we'll create an int, player heart shards, and save, load, and set it accordingly. Now, we'll also need to update the heart controller to reflect the max total health as well. So we'll change max health to max total health in instantiate heart containers and the heart containers and heart fills in start. Now we'll assign everything in the inspector. I'll move these unlocks out of the way so that it's not so cluttered. Now if we test it out, beautiful. Now that we've completed adding to the max health, we can create the mana vessel mechanic in Hollow Knight. Firstly, in the canvas prefab, we'll create an empty game object mana orbs under mana stuff. Here, we'll create 3 smaller versions of the mana container and fill and name them Orb 1, Orb 2, and Orb 3 respectively. As like in Hollow Knight, Orb 1 is at the bottom while Orb 3 is at the top. Now, we'll create a script in the Mana Orbs object, Mana Orbs Handler. Here, we'll create a bool, used mana, a game object list, Mana Orbs, an image list, Orb Fills, a float, countdown, which will default to 3, and total mana pool. Next, we'll have to move to the player controller and add a reference to the Mana Orbs Handler script, and int, Orb Shard, and Mana Orbs. Now back in the Mana Orbs handler, we'll check how many Mana Orbs the player has and set the respective number of orbs to true in both start and update. Then we'll create a function, update mana, with a float argument mana gain from. This is so that the function knows where to increase the fill from. Here, we'll check how many orbs are active and increase them accordingly by the mana gain from. The soul vessels will only be used if the knight hasn't used their mana in a while, 3 seconds. So we'll create another function, cash in mana, and we'll check if used mana is true and the player has less than max mana. If so, we'll decrease the countdown. Then, if the countdown is less than or equal to 0, we'll set used mana to false and reset the countdown. Now, we'll calculate the total amount of mana saved in the orbs by adding the fill amounts. Assuming the fills are full, that gives us 3, and since all 3 vessels are equivalent to the entire regular soul meter in Hollow Knight, we'll multiply it by 0.33. Now, we'll calculate the mana that's needed to fill up the standard meter by subtracting the mana from 1. Then, we'll make sure that the mana needed is more than 1 before we add it to the meter. We'll check if the total mana pool is more than or equal to the mana needed and add it to the player's mana. Then, we'll reset all the orb fills to 0 and calculate how much mana is left from the pool after adding the mana needed. Then, while the add back total is more than 0, we'll add it back to the orbs by calling the update mana function. Here, we'll set the argument to be add back total. Then we'll subtract 1 from it so the while loop won't become infinite. If, however, the pool has less mana than needed to fill up the meter, we'll just add the total mana pool value to the mana and reset the orbs to 0. Now back in the player controller, we'll set used mana to true and reset the countdown every time the player uses the mana to do something, when they cast spells or heal. To add to the mana in the orbs, in the hit function, we'll set the mana to add the mana gain when the mana is less than 1. Else, call the update mana with the argument of mana gain. Now, we'll create a prefab like the increase max health to add the orb shards. We'll remove the increase max health script and create a new script, add mana orb. We'll also add a script orb shard to the canvas UI. In the orb shard script, we'll copy paste from the heart shard script but change it to the orb instead. Make sure that when the orb's fill amount is 1, we add to the player's mana orbs count and reset the orb shard to 0. In the add mana orb script, we'll copy paste the increase max health script but change any health references to the orb. In void start, we'll only destroy it if the player already has 3 additional orbs. In the show UI function, we'll set the fill amount to multiply by 0.34 as in Hollow Knight. They only need to collect 3 fragments instead of 4 for the health. Okay, finally, let's go to the save data script and add ints, player mana orbs, and player orb shard. Then, floats player orb 0 fill, player orb 1 fill, and player orb 2 fill. We'll save, load, and set them accordingly. Alright, now we'll sign everything in the editor and test it out. Works like a charm. Okay, last thing on the to-do list is the inventory. Let's add it to canvas prefab. We'll add an image, inventory. This image will serve as the backing as well as the holder for the inventory items. We'll make the color gray and decrease the alpha slightly. Now, we'll create an empty game object, misc, to handle all the miscellaneous stuff. Under this, we'll create a text, inventory, and place it at the top of the screen. Then, we'll create 2 images to serve as the dividers. Now, we'll create the heart shards indicator by adding an image. set it to the heart container. Then add the fill under it. Remember to set the fill as a radial fill image. Then we'll make another fill image for the mana orb shards as well. Next, we'll make images to show the spells. This doesn't need any fancy mumbo jumbo, so simple images will suffice. Now, we'll create the abilities. I'm lazy to import the icons from Hollow Knight, so I'll make my own. But feel free to import your own icons. So firstly, we'll make an empty game object dash. Under it, we'll add the UI images to mimic the dash illustration from the unlock dash prefab. We'll do the same for the variable jump and wall jump as well. Now create a script, Inventory Manager, in the Inventory object. We'll be using UnityEngine.ui in the namespace. We'll add two images, Heart Shard and Mana Shard, game objects, Upcast, Sidecast, and Downcast, and Dash, Varjump, and Walljump. Then, create a void on Enable and set the fill amounts of the shards to their respective values in the player controller. Remember to multiply the heart shard value by 0.25 and the orb shard by 0.34. Now, we'll make sure that the icons only show if the player has unlocked them. I'll do one as an example, then I'll fast forward it. So if the player has unlocked the upcast, we'll set active the upcast to true, else false. Do the same for the rest of the spells and abilities. In the UI Manager, we'll create a game object inventory so we can access the inventory. Now, in the player controller, we'll create a bool, open inventory, and a function, toggle inventory. Here, we'll set the inventory to true if open inventory is true. Now, in get inputs, we'll define open inventory to be the inventory button, which in the input manager we'll set as I. Remember to add toggle inventory in void update. Now back in the inspector, assign all the variables and let's play the game. When we start, the inventory shows nothing as we have nothing unlocked. But as we move along, we get more and more abilities unlocked. Great! Okay, back in the inventory, let's add the sword to it since Hollow Knight also displays the nail. Now, the rightmost section is to display the descriptions of items when the cursor is hovering over it. So let's do that. Firstly, we'll create an empty game object descriptions. Then, we'll add the name of the item and description of it. I'll be using the Hollow Knight descriptions and names for simplicity's sake. We'll make one for each item we have in the inventory. Remember to set all the descriptions to false by default. Now on the icons, we'll add a script, item description. In the item description script, we'll create a game object variable, textDesk, and set it to false in start. Then, create two functions, show and hide. Set the textDesk to true and false respectively. Next, on the icons, we'll add an event trigger. We'll add an event on pointer enter, which means if the mouse cursor is over the game object, and call the show function. Then, we'll add the on pointer exit event and call the hide function. Do this for all the icons. Before we test it out, we'll assign the text desk variables accordingly. Now if we test it out, outstanding! And that's all I have for you in this episode. In the next episode, my partner Kiefer will be taking you through game states, settings, the audio manager, and menus. Thank you for watching till the end, and I hope you've enjoyed the video. Want to support what we do? You can help us by becoming a Patreon. This will give you access to the project files for tutorials, as well as patron-exclusive posts on our blog. Any support you can give will be invaluable to us, as currently we're making back about 20 cents for every dollar we put into content creation. So your patronage will go a long way to help us make this a sustainable endeavor. See you in the next video.